All right, stay with me here for a second. If we start with the number 4, we take a square root of it, that would give us 2, right? Okay, so what if we take that 2 and we square it? Well, we get right back to the number 4. The point of that is to say that a square root and a square cancel each other out. But what if I wanted to look at this a slightly different way? What if I wanted to write everything exactly the same way, except instead of writing the number as a square root, I want to write that square root as a power. So there's going to be a power right here on this 4. So let's think back to our properties of exponents. If you have a power on another power, those powers multiply, correct? And since on the right-hand side of the equation, our power is the first power, these two numbers are going to have to multiply to give us 1 for this equation to be true. Okay, so what number would we have to put here to multiply by 2 to give us 1? It would have to be 1/2. So then logically, if we compare these two equations, this square root of 4 is the same thing as a 4 to a 1/2 power. It's really just another way of writing a square root. So that's a rational exponent. Rational meaning ratio or fraction, it's a fractional exponent. So it turns out that a square root can be written as a 1/2 power. It also turns out by the same logic that a cube root turns out to be a 1/3 power. And a fourth root turns out to be a 1/4 power. It doesn't matter what goes under the root, whatever's under there is going to be raised to that rational exponent. If you happen to have something outside of a root, say 2 times the cubed root of y, that 2 does not get the exponent, but the y does. All right, let's keep going with this. Let's find a way to rewrite the square root of x cubed with a rational exponent. Well, we just learned that the square root can be written as a 1/2 power, correct? And if we think back to our rules of exponents again, this is a power on a power, so you multiply those powers. So 3 times 1/2 is 3/2. So this square root of x cubed can be written with a rational exponent of 3/2. What if we turned our powers around? What if we had a square root of x cubed? Well, the square root of x is just x to the 1/2 power. And again, we're in the situation where we have a power on a power, and you just multiply those powers. Again, it's 1/2 times 3. So you have x to the 3/2 power. So that's kind of interesting. It doesn't matter if you cube the x first and then take a square root, or take a square root and then cube the x. Either way, you end up with the same answer, x to the 3/2 power, and you get the same number. Okay, so at this point it looks like we're just dealing with a lot of exponents that happen to be fractions now. So it makes sense that we'd be using all of these rules for exponents again. If you want a refresher on these, there is a video in my feed. It's in the playlist called Math 050 videos, and it's just called exponents. You can get a refresher there. But just as a really quick couple of examples. What if we had x to the 1/2 power times x to the 3/8 power? Well, the rule says that if you're multiplying similar bases with two different powers, you just add the powers together. And it just becomes a problem where you have to add a couple of fractions. You find a common denominator by multiplying the first fraction by 4/4. In other words, we've rewritten 1/2 as 4/8. Now that we have a common denominator, we can add the numerators, and we get ourselves an answer of x to the 7/8 power. All right, what if we wanted to write a to the 5th to the 3/4 power as a single term with a rational exponent? Well, the rule is we have a power on a power, so we multiply those powers. We have a to the 5 times 3/4. To multiply these numbers together, you could think of 5 as 5/1. Multiply straight across the numerator, straight across the denominator, and you get a to the 15/4 power. I like it. Okay, we're going to do a lot of these in class. Make sure to complete the worksheet, turn it in, and I will see you there.